Can you remember how you spent October 1st, 2021? Unless this is a special date for you, then probably not. But what if you look at the photos taken that day, as well as the emails, messenger correspondence, calendar or diary entries, etc.? When some kind of clue appears, it's quite possible you'll then recall individual events, or something more general. But are you able to recall the events of that day down to the minute? This is extremely unlikely. But science can do it. Imagine that all 4.5 billion years of the Earth's existence was one calendar year. Modern technologies make it possible to establish the age of rocks in this planetary calendar with an accuracy of several minutes. Wait, in that case, it's the other way around. Scientists look at Earth's memories and establish when they happen. Granted, in real time, such a minute is tens of thousands of years, but on a planetary scale, this is an incredibly accurate result. However, it was still not enough to answer once and for all the following question. How did the mass extinction occur during the Cretaceous period? Yes, the most famous extinction that ended the reign of the dinosaurs. Let's not rush to immediately point fingers at the huge meteorite. There's at least one controversial point in this regard. It all depends on how accurately scientists can determine the age of rocks. The first thing to clarify is that the Cretaceous extinction was the last of 5 such disasters over a 500 million year span on Earth. That is, of course, if we don't include what people are doing to the planet right now. In total, 99% of all species of living organisms that have ever lived on Earth have become extinct. Far from the first, but still the largest such event occurred 252 million years ago. This was the Permian-Triassic extinction, aka the Great Dying. About 96% of marine species disappeared back then, as well as 3 out of 4 species on land. There was nothing left of the forests on the planet. Also, the Great Dying was the only mass extinction that affected a large number of insects. In many people's minds, a mass extinction happens literally in the blink of an eye. By evolutionary standards, this is true. But if you look at it from the point of view of an ordinary person, then not really. The same Permian-Triassic extinction lasted about 60,000 years. There's a logical explanation for this. The fact is that mass extinctions occur due to strong changes in the Earth's carbon cycle, because of the notorious global warming, or cooling also. When large-scale volcanic eruptions occur on the planet, they release a lot of carbon dioxide and other greenhouse gases into the atmosphere. Here again, more clarification is needed. We're talking about volcanic complexes of colossal dimensions. It was the eruption of the so-called Siberian traps that led to the Great Dying. These spat out a total of 720,000 cubic miles of lava onto the surface. By comparison, the total volume of all water in the Great Lakes is less than 5.5 cubic miles. From a scientific point of view, it may not be correct to compare water and lava, but the scale is still a bit clearer now. Together with the lava, the Siberian traps released at least 14.5 trillion tons of carbon into the atmosphere. If we were to now extract and burn absolutely all fossil fuels on Earth, then emissions from it would be 2.5 times less. As if that were not enough, on the way to the surface, the magma fell into the coal basins. This released a huge amount of methane, which is also a greenhouse gas, hence the rampant global warming and its consequences. Even ocean acidification and the loss of oxygen in the water come about as a result. The most studied mass extinction is the Cretaceous Paleogene. Logically, it's the last one. It happened about 66 million years ago between the Cretaceous and the Paleogene periods. This extinction is an absolutely unique one. It's the only one among such cataclysms that occurred due to the fall of an asteroid. But was it really so? There is no doubt that about 66 million years ago, a giant asteroid fell off the coast of Mexico's Yucatan Peninsula. It left an impact crater on the surface almost 112 miles, 180 kilometers, in diameter. It was given the nickname Chicxulub. And no matter how fantastic it may seem, the memory of that terrible event was preserved in it. Modern technologies have allowed scientists to literally parse the past into various layers and establish what happened after that fatal collision. But this still does not prove that the asteroid is to blame for the extinction of approximately 75% of all plant and animal species, including all the non-avian dinosaurs. At the impact site, the space boulder dug up the bottom of the ocean. Huge volumes of water evaporated and molten rock began to splash in its place. The resulting energy released was estimated at about 100 teratons of TNT. The most powerful thermonuclear bomb in the world is about 2 million times weaker. At the very center of the impact zone rose a high peak. It then collapsed, forming a peak ring. In mere minutes, a layer of debris 130 feet thick appeared on it. When water poured into the red-hot hole, columns of steam began to throw new fragments of rock into the air. This went on for about an hour. As a result, a crater with a diameter of about 112 miles, 180 kilometers, and a depth of about 12.5 miles, or 20 kilometers, was formed. Soup from the red-hot rocks was boiling up in this giant pot. These had rolled onto the walls of the crater, then fell down inside. During the daytime, 430 feet of new material was formed in this way. At the same time, more of this hell formed within a radius of over 600 miles, 1,000 kilometers, from the point of impact. The fireball fried everything at that distance in just 9 seconds. Trees and all kinds of different plants were destroyed, and animals in the area received third-degree burns over their entire bodies. But it was not only the territory of modern Mexico that caught fire. The red-hot pieces of rock thrown high into the sky scattered almost all over the earth. These caused a lot of fires, and the fire was followed by water. The impact caused a tsunami that could have potentially reached up to 1,000 feet high. The waves swept away everything along the coasts of the Gulf of Mexico, perhaps even around the world. And, just to add on to all this, there was then a powerful earthquake. According to the most modest estimates, its power is estimated at 10.1 points on the Richter scale. This is akin to all the earthquakes recorded over the past 160 years occurring at the same time. Oh, and the fun didn't end there either. The dying remains of trees and miraculously surviving animals were blown away by a gust of wind at a speed of 600 miles per hour. And all this action was accompanied by noise that reached around 105 decibels. This picture is more than apocalyptic. But how do scientists know that this was the case? Well, back in 2016, they took out a time capsule from the Chicxulub crater. Time capsule, in the geological sense, of course. Using a drill, they punched through the rock, pulling out 10-foot pipes. These are called cores. Over the course of 2 months of work, the researchers acquired half a mile of samples. For the most part, the obtained cores showed what an ordinary ocean floor should be like. In the strata of white limestone, there are compacted remains of extinct organisms, mostly just a variety of shells. But suddenly dark layers appeared among all this. Having studied their composition and determined the age, scientists were able to recreate the chronology of events. And yes, they really can do this. Let's get back to our endangered dinosaurs. It's obvious that the fall of the meteorite turned part of the nearby territories into a scorched desert, even with the tsunamis around the world destroying all life on all coasts. But even on such a scale, it's still not entirely clear why almost all life on the planet died out. Sulfur seems to be one of the reasons. The fact is that in the samples that were taken from the crater, this particular element was practically absent, despite the fact that there is a lot of sulfur in the rocks around it. After the impact, when everything turned into a boiling hellish soup, the sulfur evaporated. According to the minimum calculations made by scientists, about 325 gigatons of sulfur was released into the atmosphere. As a result, a layer of sulfuric acid was formed. Not only did it block sunlight, it also caused acid rain. This led to a sharp acidification of the world's oceans and soil. And raining sulfuric acid all over the planet is a pretty strong argument for a mass extinction. So then who had doubts that it was the meteorite at fault, and why did they think that? As a matter of fact, disputes on this topic have been going on since the 1980s. The reason for this was the Deccan traps. Like the already mentioned Siberian ones, this is a system of megavolcanoes, only this time it's all in India. Experts who study them are sure that the Deccan traps played their part in the extinction and were perhaps even its main cause. Scientists seem to agree that the eruption of Indian volcanoes began 100,000 years before the fall of the meteorite. In any case, this negatively affected the climate and nature, especially considering the scale of this volcanic system. The Deccan traps have been active for about 1 million years. ejecting about 135,000 cubic miles of lava back in the day. It would have been enough to encircle the Earth at the equator with a wall a mile high and 5 miles wide. By comparison, the Kilauea volcano in Hawaii erupted 1/5 of a cubic mile of lava over a few months back in 2018. The massive and sustained eruption of the Deccan Traps released a lot of greenhouse gases and other chemical particles into the atmosphere. They certainly could have led to global climate change, the same acidification of the oceans, and more. This is how, according to research, all the other mass extinctions on Earth took place. Therefore, the role of the Deccan Traps in the Cretaceous Paleogene cataclysm seems quite logical. And here we come back to the accuracy of rock dating. How much Indian megavolcanoes affected the extinction of dinosaurs depends on when they were most active. And there just so happens to be evidence that this took place after the fall of the meteorite. It's even possible the meteorite provoked a major eruption. Opponents of the Deccan theory regarding the extinction of the dinosaurs say that 75% of the lava from the traps flowed out after the collision. This carries two meanings. First off, 25% of the lava already ejected could not have caused so much damage to nature as to provoke extinction. Second, its activity after the fall of the meteorite also played no decisive role in this process. As an additional argument, scientists point out the fairly rapid recovery of life on the planet. That is, even 75% of the lava from the Deccan Traps still did not interfere with this process. And with all this, there are scientists who do not like either the first theory nor the second. They believe that climate change was the cause of the Cretaceous extinction. The eruptions of smaller yet highly gas-filled volcanoes could be to blame here. Yes, and 300,000 years before the impact. Or it could be due to repeated asteroid impacts. Over in Ukraine, there is a crater much smaller, but 2,000 to 5,000 years older than the Mexican one. Iridium was also found in the rocks of the extinction period, and this substance is only found deep in the Earth's mantle or in meteorites. So the cause of the Cretaceous extinction remains a mystery.